Welcome back to Logic Verify. So in today's video we will discuss about test bench in Verilog. What is test bench and how we will write the test bench. So let's get started. But before that, let me give you an example. Suppose a AC manufacturing company manufacture one AC. Now before selling it to the market, they will test all the basic feature, functionality, its behavior in their laboratory. And then if it is passed, if it is matching its behavior, if it is working correctly, then they will sold it to the market. Similarly, our design code, is it working correctly or not, it will first verify by design verification engineer, and if it is working correctly, then it will used in implementation in real hardware. Okay, so this is similar to test bench. The role of verifying the functionality of AC is similar to the role of test bench. So let's see what is test bench. The test bench is written to check the functional correctness based on design behavior. Okay, so we create test bench only to check the functional correctness based on design behavior. Whatever design which is written inside the code, we just check its functional correctness. We don't create any behavioral code here. We just create a model which can test this DUT. Okay, next point is the connection between design and test bench are established using port interface. So to test that DUT, we connect our design to test bench through port interface. This is the only medium through which we can connect to our design. Okay, a test bench generate and drive a stimulus to design to check its behavior. So this is the only working, and it is the main point here. A test bench generate and drive stimulus. The role of test bench is only to generate a stimulus, which is basically a test case, and then drive this stimulus to check the behavior of DUT. So we will create here all the possible test cases and then send this stimulus or possible test case to DUT. Then DUT process this signal and give output, and we will check that output to our actual output. Is it same? If it will be same, then our DUT is working correctly, and if it is not same, then there will be some bug in our design. Okay, so that's how test bench work. Let's see one example. Suppose I have one XOR gate. So XOR gate has two input A and B, and it has output as X. Okay, so it is our output port, and this is the only possible stimulus. This is only possible input signal which can be given to this XOR gate, and this is the possible output. So whenever my input signal is same, whenever my both input signal is same, it will generate 0. Like you can see here, for same input it is generating 0, and whenever my both input have different signals, it is generating 1. So this is basic, this is the simple output which I'm getting in XOR gate. So let's see how it will look if we convert it into the design code. So converting into the RTL design code. So first, whatever the design we will get, we will write it inside the module and end module. So here we have written XOR gate. Because it is XOR gate, we can write any handle associated with that design. Okay, we have two input A and B, so we have written here input A, input B, and we have one output. We have here in example it is X, but we have taken here output Y. Okay, and then whatever the XOR of A or B will happen, it will assign its value to the Y. Okay, so we are assigning whatever value we will get here, it will get inside Y. So in RTL, we just describe the behavior, what the input present here, all the possible functional behavior we write inside the design. Now let's see how we will create it inside a test bench, how we will verify this design DUT code inside our environment, test bench environment. So this is my test bench environment. Here I have written all my design part, and in this part I will write the test bench environment. So let's see. I will write that test bench in module also. So first we will declaring a test bench as a module. So here module test, and then we declare set signal that have to be driven to the DUT. So whatever input, whatever signal of DUT is given here, we will write it inside our test bench. So remember one thing, The input of duty we will write here as reg A, and then reg B. And the output of duty we will write here as wire Y. Okay, so why we are writing input as res and output as wire? In a test bench, we typically generate stimulus test case inside initial or always block, and any signal assigned in procedural block must be declared as a reg. So that's why we are writing here as reg, and we will not drive any values, any stimulus to output. That's why we have written here wire. We are just using it for connection with our DUT. That's why we are using here wire. Wire is basically used for physical connection between test bench and our design. Okay, so our input signal declaration part is over. Now we will instantiate a design, which means we will create a copy of this design code here in our test bench environment. By doing this, we can only test our DUT code and we will connect our port interface with test bench variable. So let's see how you can create here. So I'm taking my duty handle here, and then I'll create one handle here. Now I will connect my test bench to now I will connect my test bench variable to duty variable. So first signal will be our duty signals. So here A, and I will link it to the test bench variable, which is small a, and then here my instantiation and interface part is over. Now, now we will generate all the possible stimulus and signal here. So we will generate our stimulus in initial block, initial begin. So zero 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 one, here it will be 10 and then 11. So this is only possible stimulus and test case which we can generate for XOR gate. So let me introduce here timing also. So that it will be having better clarity. Hatch 10 semicolon, hatch 10 semicolon. And after completing all the signal, we will stop our stimulus here. Okay, initial begin, end, and then end module. So here my test bench part completed. So what I've done here, I have declaring all the test bench variable here. Now I have created here a copy of DUT, and then I have connected my test bench to the DUT through their signal. And after that, I have created all the possible stimulus which we can generate for XOR gate. Okay, now we will drive this stimulus to our DUT, and then we will compare its behavior. Is it working correctly or not? So where we can see the output. So to see that output, we will write here another block. I will write here dollar monitor, and then inside it I will write time. and okay. Now we will see all the output here by using dollar monitor. In another video, I will discuss why I have written here dollar monitor, what it will do. But for this moment, you just need to remember it will display the value. It will display value here. So let's run this code. So here you can see if my input is 0 0, then I am getting output as 0. If my input is 0 1, then I am getting here 1. If my input is 1 0, then I am getting here 1. If my input is 1 1, then I am getting 0. So if my both input signal is same, then I am getting 0. And if my both input signal is different, then I am getting here 1 positive signal. So this is the behavior of XOR gate. Now we are getting actual output. Now my both expected output and actual output is same. It means so the design which is written here is actually correct. Now you can implement it into hardware.